Welcome to the ISTH Gene Therapy for Hemophilia monthly update. This update is part of an ISTH comprehensive educational resource designed by leading experts for the global hemophilia community to help you stay abreast of the evolving science and latest clinical advancements in gene therapy in hemophilia.
Hello, my name is Guy Young. I'm a pediatric hematologist, although I take care of both children and adults with hemophilia. I'm the director of the Hemophilia Treatment Center at Children's Hospital Los Angeles and a professor of pediatrics at the University of Southern California Keck School of Medicine. And I'm happy to speak to you today and answer a couple of questions about gene therapy. Really, one of the main questions that has been circulating around gene therapy relates to durability. Obviously, the entire goal of gene therapy is to provide essentially a functional cure of hemophilia, meaning giving the patient a normal factor level that can be durable, that can last, well, hopefully a lifetime. But as we have seen from some data from Factor VIII clinical trials of gene therapy, there does seem to be a decline over time, a slow, albeit steady decline over a period of several years, at least for one of the products that's been studied far out, BMN 270, and we may also see the same with other Factor VIII products. Interestingly, we don't see the same thing with Factor IX, at least thus far. Factor IX gene therapy does seem to be durable. So this begs the question, what is the difference between Factor VIII gene therapy and Factor IX gene therapy that might account for this? Now, first, let me tell you, we don't have the answers. We don't really know what the differences are. But let's explore a few things that are different about Factor VIII and Factor IX gene therapy. With Factor VIII, we're using a B domain deleted transgene. So we're not putting the whole Factor VIII gene in there. And while the B domain is not required for Factor VIII function, once you're working in the coagulation system, there may be some role for it when it comes to stabilizing messenger RNA, for example. And that may be a reason why we may see a different level of durability with Factor VIII gene therapy, because we're not using the whole Factor VIII gene. And whether that is true or not does remain to be seen. The second important thing is that the Factor VIII gene therapy and the Factor IX gene therapy are transfecting hepatocytes, but hepatocytes are not the natural site of synthesis for Factor VIII. Factor VIII is made in endothelial cells in various organs, and including the liver and endothelial sinusoidal cells of the liver, but not in hepatocytes. Factor IX, however, is made in hepatocytes. So when it comes to gene therapy, when we're transfecting hepatocytes, with Factor IX, the natural site of production, the hepatocyte, is the cell that's being transfected, whereas in Factor VIII, it's not the natural site of production. So could that have something to do with the durability? The third issue has to do with the fact that Factor VIII is a much more complicated protein. It requires very unique folding that has to occur in the endoplasmic reticulum Golgi complex. Somewhere along there is a folding of the Factor VIII protein. And if it's not folded properly, that can result in what we call cellular stress or an unfolded protein response, which could result in hepatocyte death, and that could lead to loss of expression. That's an area that's very much being explored. And so those are some important differences between Factor VIII and Factor IX gene therapy that may, at least in part, explain these differences. The other question is immunogenicity. We know Factor VIII is more immunogenic than Factor IX based on the fact that more Factor VIII patients get inhibitors. Could there be some low-level triggering of immunogenicity against Factor VIII that we're not really seeing in our lab tests? Because I will tell you that with Factor VIII and Factor IX gene therapy, we have not seen any obvious inhibitors. There's no increase in the Bethesda titer in any of the trials that have been seen. So this would have to be something that's a little bit different in the way of immunogenicity, something more subtle that we can't pick up with our usual assays. Maybe there's something different there. So the bottom line is there are a lot of differences between Factor VIII and Factor IX gene therapy, so don't lump them all together. And it could be that those differences, as I explained, may impact on the durability of the gene therapy products, as we have seen thus far, with some questions about Factor VIII gene therapy durability, whereas less questions around Factor IX. As far as that's concerned, we might consider moving beyond AAV. Are there methods other than AAV that are being explored that may impact on this durability? And course, we don't know the answers to that, but just be aware that lentiviruses are also being explored as a potential gene therapy option in hemophilia. There are also methods of cellular gene therapy where we will add the gene into hematopoietic stem cells. That may be a possibility as well. There are also non-viral methods using lipid nanoparticles that are being explored, and even gene editing as well. So the story of gene therapy in hemophilia, I am sure, is not going to end with AAV. It's starting with AAV. The first products will be AAV based, but moving forward in the future, we may have products that are not AAV based, and maybe that will have some different outcomes with respect to durability. Thanks for listening to that question and answer.